Hey everyone, we're discussing trigonometric graphs. Let's start with the first graph, which is y equals sine x. The graph for sine x, where x is the value in degrees, the angles in degrees. Alright, so in your calculator, when you'll find sine 0, you'll get 0. When you'll find sine 90, you'll get 1. Then sine 180 will be 0. Sine 270 will be minus 1, and for sine 360 you'll get 0 again. And same for these particular angles. So you'll simply join these points with a smooth hand, with a free hand and a smooth curve. So you'll get something like this on both sides. And this graphs repeat itself after 360 degrees. So it looks the same after 360 degree from here and here as well. So its periodicity is 360 degree. Periodicity is when the graph starts to repeat itself. So the periodicity of graph for sine x is 360 degree. Alright, let's talk about graph for cos x now. Your calculator will give you cos 0 1, cos 90 0, cos 180 minus 1, cos 270 0, and cos 360 0. And after 360 the graph repeats itself. Just like here, it will repeat itself. The same curve will be repeated again. So again, the periodicity for graph of cos x is also 360 degree, because after 360 degree the graph starts to repeat the previous trend. And similarly you'll get these marks over here, and then you'll join them with free hand and a smooth curve on both sides. And also notice that the graph of cos x is symmetrical about the y-axis. Okay. Graph for tan x. Okay, for tan x you'll notice that tan 0 is 0, and then tan 90 is infinite. This will be infinite, and any value between tan 0 to tan 90 will give you positive increasing values. So the graph will look like this. It will never touch the infinity line. So if I make a line like this, the graph will never touch this. Similarly, the graph will never touch the line at negative 90, and between 0 to um, negative 90 the graph has negative values which keep decreasing, so hence a trend like this. Similarly, tan 180 is again 0, and between tan 180 and 270 we'll get a similar graph as before. So the periodicity of tan x is 180 degree. The graph for tan x is 180 degree, because after 180 degrees, if the graph from 0 and beyond was like this, then after 180 degree the graph will repeat the same trend from 0. So that's the basic sketching of graph of sine x, cos x, and tan x. Also, if we'd like to talk about these formulas here, I think I saw these formulas in a book and I copied them in the worksheet, although I haven't seen a question on graphs that is using these formulas in particular. This one is tan theta equals tan 180 plus theta. So we've done this formula in detail while doing trigonometric questions, and we're pretty familiar with it, which says that sine theta equals to sine 180 minus theta. So if theta is 90, then sine 90, oh, that will just give sine 90 equals sine 90. Let's try some other value. Sine 30 should be equals to sine 150. So sine 30 is somewhere over here, and sine 150 is somewhere over here, and they will both have the same value. Okay. Similarly, cos theta equals 360 minus theta. So let's say if cos theta is if theta is 50, then cos 50 is equals to cos 310. Let's see from the diagram. Cos 50, let's say somewhere over here, and then cos of 310 will also be here. This would be 310. So they are both have the same value. And similarly for tan theta is equals to tan 180 plus theta. So tan 45 will be equals to tan 125. So if this is tan 45 is 1, then tan 125 will also be 1. No, that was tan 180 plus theta. So 225, sorry. So 225 will be somewhere over here as well. And the answer, the value of y for both is 1 simply. Okay. 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 So sine, now the graph for minus sine x. So sine x graph was this. Sorry, the other one, the upper one. This is the graph for sine x, and graph of minus sine x is simply its mirror image on the on the x-axis. So the graph will simply invert, and the rest will remain the same for both sides. Okay. Now for cos x, same story. The original cos x was this curve. Now reflect this on the x-axis and you'll get this new curve. 1 becomes minus 1 and minus 1 becomes 1. Okay. Next is the graph for tan minus tan x, so it will be a reflection on the y-axis. So this was the original graph for tan x. So the graph for minus tan x will be a reflection of it on the y-axis. Okay. Next up is graph for functions like 2 sine x or 5 sine x or 5 cos x. Okay. So again, this is the graph for the original sine x from 1 to minus 1, a curve like this. Okay, so then if the question says to draw the graph of half sine x, then you simply multiply the magnitude with half. So 0 times half is still 0, 1 times half is half, 0 times 0 is 0, and so on. So the magnitude of the previous original graph gets multiplied with half, and it holds true for the graph of sine x and for the graph of cos x and tan x as well. So you'll get a curve like this on both sides of the y-axis. Similarly, if the question is to sketch the graph of 4 sine x, then you'll multiply the magnitude with 4. So 0 stays 0, 1 becomes 4, 0 stays 0, minus 1 becomes minus 4, and so on. So we'll get a graph like this, and so on. Okay. Next, we're discussing cases like graph of sine x plus 4. So what this plus 4 will do will simply move the graph 4 places up at every point. So 0 becomes 4, 1 becomes 5, minus 1 becomes minus 1 plus 4, 3, and then you join these points simply with a smooth graph, with a smooth curve. 0 becomes 4, this 0 also becomes 4, and join these points. Similarly, when it's sine x minus 3, every point on the y-axis gets subtracted by minus 3. So 0 becomes minus 3, 1 becomes minus 2, 0 again becomes minus 3, minus 1 becomes minus 4, and then you join these points with the smooth curve. And same holds true for the graph of cos x and tan x. Okay, so we just discussed cases like this, cos x plus 2, which would mean simply move the graph of cos x 2 units up. We discussed the sine graph, but it holds true for the cos case as well. Alright, so now we're discussing cases where there is a shift along with this inside the brackets. So when it's cos x, let's say plus 45, then this moves the graph 45 degrees to the left. Just like in the case for quadratic graphs, when we had cases like x minus 4 whole square, it would move the original graph of x, let's make it plus 4, it would move the original graph 4 units to the left, not right, because x plus 4 would be equals to 0 and x equals minus 4. So the graph would be shifted to minus 4 from 0. Similarly, here the graph will go 45 degrees to the left. So let's see how that's happening over here. This is the original graph, right? Let's just take this portion only. Okay, now move this graph 45 units to the 45 degrees to the left. So 0 becomes minus 45, right? And then this is the first point, and initially we had a fall at 90. The graph was meeting x-axis at 90. Now it will meet x-axis at 45 because it's going 45 degrees to the left, and then you can continue your whole graph. This was minus 90, so this would be minus 90 minus 45, which is 1 minus 135, and so on. And next you can just complete your graph using symmetry. Okay, and there's another case done over here as well. Graph for cos x minus 135. So this will move the graph 135 degree to the right. So this 0 will now lie on 135. So, and this value minus 90 will lie on minus 90 plus 135, which is I believe 45, yes. And then this purple, this one, which was originally at, where's the original graph? No, here's the original graph. This was at 90. This will go from 90 to 90 plus 135, whatever that is, and then you join it using a smooth curve. So a curve like this, every point has moved 135 degrees to the right. So the curve will look something like this. Okay, now cases where we've discussed before for graph of 3 times sine x, uh, every value of the y gets multiplied with 3. So now we're discussing a different case where the number will be multiplied with the x inside the bracket and not outside. So what's happening here? Let's look at the original graph first. Okay, so what's happening now, that if I'll substitute 2x equals 0, I get x equals 0. So this would still remain the same, 0. If I substitute 2x equals, this was 90, so 2x equals 90, I get x equals 45. So now, for previously my maximum point was occurring at 90, now this maximum point would occur at 45. So here is my maximum point 1 at 45. Similarly, the next x intercept was at 180, so 2x equals 180. So x equals 90. So the graph would fall back here. So every angle is being multiplied with 2 and the magnitude remains the same. And there's another case, I guess. No, there's just one case discussed here. So simply multiply the magnitude with simply equate the angles. So if it were half sine half x, then we would equate half x equals 90 in this case, and then x equals 180. So now we're getting the maximum point at 180 and then the fall another 180-degree later, and so on. So that's how you deal with such questions, and it'll remain the same. The concept will remain the same for the graph of cos x and tan x. Okay. Okay, so again the graph for cos 2x. So same concept here as well. So the we were getting the y-intercept at 90, but now we'll get the y-intercept at the second y-intercept at 45. Sorry, the x-intercept, not the y-intercept. So it meets at 45, and here it was meeting at minus 90. Now the graph will meet the x-axis at minus 45 instead. So this is what the graph looks like for cos 2x. Similarly, the case for tan 2x as discussed. So this is the original graph. Now this point will occur here instead. So the graph will look like this. Okay, so the first past paper question, which is solve the equation 3 cos x equals to 1 from 0 to 360 degree. So cos x equals 1 over 3. So where in the graph is cos x? Okay, it doesn't ask us to use the graph, so it's not necessary to use the graph. So we've learned it the other way as well. Cos inverse 1 by 3 gives us 70.5. So value of x is 70.5, and also we know we've also discussed the formula in the start of this worksheet that cos theta is equals to cos 360 minus theta. So either use that. So cos 70.5 will be equals to cos 360 minus 70.5, which is 289.5. Or if you can recall from the previous worksheet that when the absolute angle is coming out to be 70.5 and this is plus 1 over 3. So we have cos positive in the all students take calculus. In the first quadrant, which may and the anti-clockwise angle is 70.5 with the x-axis, and the other anti-clockwise angle is this one, which is 360 minus 70.5. So this is how we get this second angle. And also let's see how we can do that from the graph. So where's 1 over 3? 1 over 3 means 0.3333, so we can't accurately uh, point that out from our graph. It's somewhere over here. So read these values. Yeah, we can't use this method because we can't read the values precisely. Alright, so on next part is on the same graph sketch the graph for sine x. So you'll enter sine 0 in your calculator, you'll get 0, then you'll enter sine 90, you'll get 1, and so on, and you'll get 0 here and minus 1 here and then 0 again, and then you'll join these points free hand using a smooth curve, showing a smooth curve. Okay, so the previous question I believe was from the sample paper 2020 to, yes, from syllabus 20 to 2022. Okay, and this one is from a very old paper, May June 10. Okay, so let's see what this is about. We're given the graph for sine x. This graph is for sine x, and then we're giving the graph for cos x. This one is for cos x. The purple one is for cos x. The this is cos x. No, in fact, I think I'm sorry, this is sine x. So the green graph is sine x, and the purple curve is cos x. Okay, so the question says use your graph to solve these inequalities. Cos x minus sin x minus cos x is 0. So where in the graph the distance between the two is 0? It's somewhere over here. So read this value. So it says it's read this value, so it should be between 43 to 47. Next is sin x minus cos x equals 2.5. So where in the graph is the difference between the two graphs? 0.5. And also note it's saying sin x minus cos x. That means green graph minus purple graph. So the green graph should have a bigger value, which is in this region. So where in the graph is the difference between two graph equals to 0.5? So 0.5 is note 10 boxes. So where in the graph is the difference between the graph equals to 10 boxes? So it's, I'm not sure, I can't really read from here. So let's say these are 10 boxes here. These make 10 boxes, so I'll say my answer is, here it says between 64 to 68. So you will read that value. I think it'll be a little before this. So 10 boxes, 1 2 3 4 5 6 7 8 9 10, yes, roughly here. So read this point here, which is these are 10 boxes, which means the difference between the two graphs is 0.5 here, and this should be between 64 to 68. Okay, next I've given a couple of uh, questions on sketching. They're not from past papers, I've just made those questions up, but I think they're good questions for to practice sketching. Alright, so we need to sketch minus 3 cos x. I would like to first sketch cos x. Cos x is like this. So this is roughly cos x. Now I'll sketch minus cos x. So minus cos x means flip the graph on the x-axis. So take a mirror image on the x-axis. So the graph would look roughly like this. Make these graphs with very light dotted lines because we'll be rubbing these later. And then I need minus 3 cos x. So now I'm multiplying this with 3. So this becomes minus 3. This 0 becomes stays 0, and this uh, minus 1 times 3 minus 1 times, yes, 3 is, okay, sorry, I'm multiplying the green graph with 3. So this was 1, this becomes 3, and then this was 0, this stays 0, and then this was minus 1, which becomes minus 3. So the new graph should look like this, and this graph is symmetrical about the y-axis, so we'll get a similar graph over here. So this is also the answer. Yes, so first you'll make the graph of cos x, and then for minus cos x flip the graph on the x-axis and then multiply this with 3, multiply everything, the magnitude with 3, every value on the y-axis with 3, and you'll get the next graph. Okay, so we need to plot the graph of 2 sine x plus 2. So let's just first draw the graph for sine x. So sine x was like this. Okay, so for sine x, this value is 0, then 1, then 0, then minus 1, then 0, and so on. So we roughly get a graph like this for sine x. And similarly, we'll repeat this graph here. It's a very bad looking graph, so it should be something like this, smoother curve. Alright, next I would draw the graph for 2 sine x. So for 2 sine x, I'll multiply every value on the y-axis with 2. So this stays 0, this becomes 2, this stays 0, this becomes minus 2, and this stays 0. Okay, so this is the graph for 2 sine x. The next we need the graph for the original graph that is required, 2 sine x plus 2, which means move this graph 2 units up. So this 0 becomes 2, this 2 becomes 4, this 0 becomes 2, this minus 2 becomes 0, and this 0 again becomes 2. So we'll get a graph like this and repeat this trend here. So yes, the answer also looks like this. So this is how we make the graph for, sketch the graph for 2 sine x. For 2 sine x plus 2. Okay, so next we need to sketch the graph for sine x plus 90. So again, first we'll sketch sine x. We get 0 here, 1 here, 0 here, minus 1, and 0. So get something like this. And continue the trend here. Alright, now I need the graph for sine x plus 90. Plus 90 degree means I have to shift the graph uh, 90 degree to the left. So shift it 90 degree to the left. So now this will fall here. This will fall 90 degree to the left. This will fall 90 degree to the left. So we're getting a graph like this. It should be a curved graph, not a... Okay, and then continue it from here. So this is the graph for, yes, we're getting the same graph for cos x plus 90. Plus means move left 90 degrees. Also remember, if you're asked to sketch these graphs, you'll have to make these grids on your own. So you'll make y-axis, x-axis, and mark these 90, 180, 270, and so on both sides with 90 degrees interval. Alright, so last question of this worksheet is sketch the graph for tan x minus 45. So first I'll be sketching the graph for tan x, which is tan 90 is infinity, yes, and tan minus 90 is infinity. These should be dotted lines. Okay, and this is minus infinity. This is not the actual graph, this is just for explanation 6. And tan 0 is 0, and then we should get graph like this. Original graph for tan x. Next we need graph for tan x minus 45, which means move the graph 45 degree to the right. So 0 falls here now, and 45 degree to the right, and 90 will fall at 90 plus 45, so somewhere over here in between 90 and 180. And this minus 90 will also move 45 degrees to the right, and fall here. So in between these, now we'll be drawing this graph, and it'll continue to the left and the right wherever it can. So that's how we sketch the graph for tan x minus 45. Remember to include these points here and this one for this particular question. And we're done with the worksheet. I'll see you next time. Take care.